Hey y'all, let's cover lesson 6, an introduction to integers. Okay, so we've just finished our first exam. We've already discussed a couple different sets of numbers. We use these in different situations. So there's the natural numbers. Remember, those are 1, 2, 3, 4. It's what we use for counting. The whole numbers, 0 is added to the natural numbers. And that's how we answer the question, how many? So now we're going to turn our attention to a third set of numbers. But in order to properly discuss the real world situations in which these happen, like banking or temperature, we need more numbers at our disposal besides just those two sets. All right, so let's go with an example. You put $5, you deposit $5 into your bank account. All right. You would see this on your statement as $5. However, if you spend or you withdraw, which is the word that's used for the banking, the $5 or another $5 from your account, how would this appear? So let's think about that. It would appear as a minus the $5. They're going to put minus 5 for how that would appear. All right. If you deposit $5 into your account, and then the next day withdraw $5 from your account, what does this look like overall? Well, you would have $5 put in, $5 put out. So therefore the account overall from the beginning to the end would have no change other than those two transactions. So there would be no change. No change. No, there's nothing that happens. Put 5 in, take 5 out, 5 in, 5 out, no change. So 5 plus or minus 5 is 0. All right, so for every whole number A, don't freak out on using the term A. There's a unique number, negative A, and it's called the opposite. It's called the opposite or the negative, which is what you just heard me use, of A, such that A plus that negative A, because we know what plus is, A plus that negative A is going to give us a 0. Okay. All right. So note that negative 5 is pronounced in one of many ways, one of two ways. One, which you've already heard me say, is negative 5. And the other way is the opposite of 5. The opposite of 5. Those are both negative, both the negative 5 that you're seeing. You can tell what I'm going to be using a lot. All right, pardon me. To locate the opposite or negative of any whole number on the number line, first you locate the whole number. So first we find 5. Here's 5 right here. Granted, this is a little bit blurry. That's about as good as I can get. Here is 5 right here. And we've got a solid dot representing it. The opposite is the reflection of the whole number over the 0. So here's 0. If the distance from 0 to 5 is 5. So the negative 5 has to be the same distance, but on the other side of 0. So the distance from here to here is 5 as well. They're both the same distance. So that I want you to understand, distance from 0 is always measured by absolute value. So absolute value of 5 is 5, and the absolute value of negative 5 is 5. I just proved that by showing you the distance from 0 to 5 is 5, and the distance from 0 to negative 5 is 5. So I want you to understand that as well. All right. By locating all the opposites of the similar fashion, we arrive at the number line representation below. So we've got everything to the right of 0 is the positives, the positive numbers, 1, 2, 3, 4, 5, 6, on to infinity. The numbers to the left of 0, okay, are the opposites of the numbers to the right in the same order going the other direction. So the opposite of 1 is -1. The opposite of 2 is -2. So everything to the right of 0 is positive. Everything to the left of 0 is going to be a negative. All right. These are called the integers. The integers is the infinite collection of numbers consisting of all of our whole numbers. So our whole numbers, their opposites, and 0. So integers is labeled like this. And it's just the set from negative infinity, -3, -2, -1, 0, 1, 2, 3, and then all the way to positive infinity. Please keep in mind, integers we have not discussed fractions or decimals. That is not an integer. We're not going to talk about either one of those in this section either. Between now and the end of this exam, we are going to only talk about integers, no fractions, no decimals. We haven't gotten there yet. We will, I promise. So let's go this route for the rest till this second exam is done. Recall, as with whole numbers, as we move on the number line to the left, the numbers get smaller. Okay, same thing as if we're going from 7 to the left, our numbers are getting smaller. They continue getting smaller as they go to the left after 0 as well. The numbers, as we move to the right, the numbers get, well, larger. Just like they did with our whole numbers. If A is to the left of B on the number line, well, that just looks like A is to the left of B. All right, it's right here. That means that A is less than B. And we write that as A less than B. All right. If A is to the right of B on the number line, so if this is B and this is A is to the right of B, that we say that A is greater than B. And that's written as A is greater than B. Arrange the integers 4, 0, -4, and -2 in order from smallest to largest. So from smallest to largest. What is our smallest integer from this set? So it's going to be, if you look at your number line up here, -4 is less than -2. So it's going to be -4. Then it's going to be -2. Then 0. And then 4. Okay. All right, the next one is compare each of the integers, -3 and 5. When they say compare, that means we're going to use A is less than B or A is greater than B. All right, so we've got -3 and 5. Is -3 less than 5 or greater than 5? It is less than 5. All right, then we take -2 and -4. -2 is either less than -4 or greater than. -2 is greater than -4. And the last one is -23 and -24. -23 is either less than -24 or -23 is greater than -24. -23 is going to be greater than -24 because as you're moving to the left for your negative integers, the numbers get the number inside the net with the negative is getting bigger, but the numbers themselves are getting smaller. Okay. All right. Next page. So we noted earlier that every whole number has a unique number called its opposite. And the same is true of the integers. So the opposite of 5 is -5. It makes sense then the opposite of -5 is 5. So then that means that the opposite, I'm going with what they're saying here, that the opposite of -5 is, I'm using the language of math, the opposite of -5 is positive, so it's just 5. All right, so a negative times a negative is what we're doing here mathematically, and that's going to equal a positive. So that means let A be an integer, then the opposite of A, so the opposite of A is just A. Or for an example, the opposite of 4 is just 4. All right. Simplify this. And I can say this two ways. We've been saying the opposite. It's also negative 13, or a negative times a negative is the other way to think of it. So the opposite, whichever one you like, the opposite of 13 is 13, or the negative of -13 is positive 13. Same thing for an opposite of opposite. It gets tongue-tying for me. Negative 119 is just positive 119. Okay. If A is an integer that lies to the right of 0 on the number line, so we've got a number line, and here's 0, and they're saying that A is an integer that lies to the right of the number line, then A is a positive integer. That means it's a positive A. That's the way you can say it. But a positive A is just A. We don't have usually a positive representing it. Okay. If A is an integer that lies to the left of 0 on the number line, A is a negative integer. Okay. Note, the integer 0 is neither positive or negative. The integer 0 is neither positive nor negative. Okay. And I've already went over this, but I just want to make sure that I kind of want to think about it as I'm going through it to make sure you have it. The absolute value, which I discussed on the previous page, of an integer is defined as this. So it's the distance from the origin 0. The distance from the origin 0. Okay, or 0 if you want to write it out. All right, so absolute value is written as, let's say the absolute value of A is written as the absolute value of A, and that's what's said. Because the absolute value of A, the absolute value is a distance, then the value has to always be positive. The absolute value of a number is always positive, because you can't measure distance with negative. It would be like me measuring this desk. I can't take a tape measure and measure this desk and say, oh, this desk is -4 feet. That's not possible. So it's always going to be positive. If you're driving from here to another location, it's always going to be positive. It's measuring distance. All right. So the integer 4 is 4 units from 0. There's a distance from 0 to 4 is 4. And so we say the absolute value of 4 is 4. Okay. The integer -4 is 4 away from 0. So we'll say the absolute value of -4 is 4. All right. Determine the value of absolute value of -7, the value of absolute value of 3, and the value of the absolute value of 0. Well, the absolute value of -7 is just 7. The absolute value of 3 is just 3. Has to be positive. And then the absolute value of 0 is 0. Because there's no distance between 0 and 0. All right, remember absolute value is the distance from 0. So determine the value of A is -8, or the opposite of 8. And B is the opposite of the absolute value of -8. All right. So -8, or the opposite of 8, which you're not going to hear me say very much longer, is just 8. All right. Negative, the absolute value of -8, is still negative. And then this is going to be a 2 pieces here. The first one is, what is the absolute value of -8? That is just 8. All right. So just to keep it separate, it's no longer an absolute value of -8, it is just 8. So what's the negative of 8? -8. Okay, you didn't have to put the parentheses, just for me to represent that what's coming out of that absolute value of -8 is 8, just to make sure there's no confusions. And then we have to apply that negative on the outside to the 8, and we get -8. All right, last piece of this, last page of lesson 7 is profits and losses for the first 6 months of the fiscal year for a small business are shown in the table below. Profits and losses are measured in thousands of dollars, and a positive number represents a profit, while a negative number represents a loss. So we're going to create a bar graph representing the profits and losses for this business for each month of the first half of fiscal year. Okay, so I'm going to create a bar graph. All right, so I'm going to need a value here. Just going to create this. And then we're going to have profit losses over here. I just have to label what my stuff is. And then we're going to have months. We're going to have January, February, March, April, May, and June. So January, February, March, April, May, and June. All right. The reason it looks so weird is right here is my 0. Okay. Anything above this line is going to be positive. So 2, 4, 6, 8, 10, 12, and I'll put up to 14 because we go up to 12. So I want to make sure 14, we're going a little bit further. We're also having to go down to at least a -4. So below the 0 horizontal axis is, I'm going to put -2, -4, and -6. Okay. In January, our bar graph is going to represent 10. So this is January, and it's going to go up to 10. All right, so there's my bar for January representation. February, we're going to go up to 12. Here's February's, and it's going to go up to 12. The bars should be the same, but not an art person. Okay, then March, it comes down to 7. So between 6 and 8 is March. We have to go up to 7. Looks to be right about there. Okay. April, -2. So we've got an issue. Profit. They no longer have a profit. They've had a profit these first 3 months, but now they have a negative, which means they have a loss of 2. And it's measured in thousands of dollars. So they're losing $2,000 for the month of April. I would worry that they have somebody stealing. And it's going to come down to here. All right. Then in May, they're losing another $4,000. Not a good time of the year for them. So it comes down to a 4. April and May are not good months. Maybe they again have somebody stealing. First thing I'd look at. And then June, they are going back up. So it looks like they either fired this person or something's turned around. And this labels out right about here. And this is our June. They're back up to making $5,000. So there's our bar graph representing what is happening for that. We have our labeling. Well, I need my title down here, months. And then I've got my profit and losses over here. And that's going to be represented in the thousands of dollars, just so that you understand what this is measured in thousands of dollars. Okay. Just so that you know what's actually happening in the bar graph. You don't need to fill in the bars if you don't want to. It doesn't matter to me. The most important thing is that they're represented with the correct months and they're going up or down based on what's happening in this. Remember, time is always your, I'm going to be on your horizontal axis. So you want to make sure and always put your time or your months or your years or whatever down here. All right, then the last one here is the table below contains low temperature recordings in degrees Fahrenheit on 5 consecutive days in Fairbanks, Alaska in 1995. And it says create a line graph for this data. All right, so I'm going to just create a graph. And I've got 5 days. So I'm just going to put those specific days on here. 1, 2, 3, 4, and 5. I've got one, what is it? It looks like January 21st, January 22nd, January 23rd, January 24th, and January 25th. And these are my dates. Okay, so I've labeled it and I've got my numbers hatched. And then the other piece of it is this has to do with the low temperature recordings. So this is the low temperatures for these dates. All right, and it goes from what's our lowest to our highest. The lowest is -28. I'm probably going to go down to -30, and my highest is 10, so I'll probably go up to 15. Note, I'm not going down to -28. I'm going to start here at -30. And I'm going to go by 5s. -25, -20, -15, -10, -5, 0. Now I'm going to the positives. 5, 10, 15. I think that's about as high as I need to go because my highest is 10. So now on January 21st, my low temp was 1. So I'm going to come up to where I have my positives. Here's 0, here's 5. So I need to come just above the 0 and place my point. January 22nd, we were at a low temp of 10. So I need to come up to where 10 is and place my point where they come together. January 23rd was 5 degrees. Right about there. January 24th was -20. Whew, tough time for that one. And then January 25th was -28. So right about there. All right, then all we have to do is connect the dots. That was always a fun thing to do in school, or maybe we thought it was tedious. And now in our lives, we're like, gosh, man, don't you just miss the times we could just connect? Maybe just me. All right, so there is my line graph representing what is happening in Fairbanks, Alaska on 5 days with the low temperature recordings. They were not heading for a good time. That's it for this lecture. If you have any questions, please make sure and bring it to my attention so that I can help you understand it. Have a great one, and I'll talk to you later.